In this question here, you're being asked to explain how this substrate here, when treated with base, turns into this structure here. So it's a mechanism question. So remember, anytime you're doing a mechanism question, focus on what you're being asked to do. You want to explain how this turned into this. What a lot of people will do in something like this is they'll start saying, well, won't this hydroxide come in here and do an SN2, or won't it remove adjacent protons to do the E2? Yes, it absolutely can, but that's not what you're being asked for here. So whenever you do a mechanism, forget about major products, forget about minor products. Only focus on what you're being asked to explain, because your only goal here is to explain how these reagents became this structure here. That's it. You have to provide a logical flow of how electrons moved and bonds formed and broke, how all of that occurred to turn into that structure. All right, so we can clearly see that we're going to form a ring here, and that ring is going to have a sulfur in it. So at some point, this ring, this sulfur is going to act as a nucleophile, and it's going to kick something out and form a ring. Well, we can see over here on the left side that we have sulfur here. There's a proton on there. That proton's relatively acidic. So we're in the presence of base. So the first thing you want to be thinking is this base is going to remove that proton. So let me redraw the structure here so we actually can look at it. Let me do this in a different color. And I'm going to draw the bond between the sulfur and the hydrogen there. All right, so what can happen here is the base can grab that proton. And when it grabs that proton, those electrons between the sulfur and the hydrogen, they stay on the sulfur. So sulfur gets the electron that belongs to hydrogen. And that's why it's going to end up with a negative charge. Now, I can show the lone pairs that exist on here if I want. I don't have to. It's kind of lazy to not do it, but that's how we are. All right, then the next thing we got to think about is, well, how can this thing close? How can we form a ring here? Well, we do have a bromine here, and that bromine is pulling electron density from this carbon here, which means this carbon here ends up with a partial positive charge, which is going to attract the electrons from the sulfur. So that's one way that we can actually close this thing up. So I'm going to number the atoms here that are involved. It has nothing to do with nomenclature. I'm just numbering these. I'm going to call sulfur 1. This carbon 2, 3, 4, and 5. Okay, so those are just the atoms involved there. So what will happen next is the electrons on sulfur can act as a nucleophile by attacking the positive charge on carbon that I labeled 5. That's going to kick out the bromine leaving group here. All right, so we're going to form a 5-membered ring with sulfur in it. Okay, and I'll just put those numbers back on there. I'll say, you know, this sulfur was number 1. I can go left or right here. It won't matter. I'll say this is 2, 3, 4, and 5. So the sulfur came in, attacked carbon 5 that I numbered 5, and it kicked out that bromine. Well, also on carbon 5, there's still an ethyl group. So I have to make sure that I put that ethyl group back on carbon 5 there. And that's it. This would be a logical mechanism for how that substrate, when reacted with base, turns into this product. At this point, we have answered the question.